Welcome to Vinsa Mathematics and welcome back to the channel. Today we are going to learn the question sessions of beta and gamma. Okay. So question session means that we will cover all the questions of beta and gamma. So first of all, we have to become fearless. Okay. And becoming fearless is important in mathematics. So how to become? So simple, we don't have to consider the consequences. Just we have to learn and focus on the present. And learn is what? Learning is fun. Okay. Clear to you. Learning is fun means like what? Like we used to learn in childhood. Simply don't again consider the consequences, just learn and we will rejoice. Okay. So now coming to the question sessions without wasting any time. So if you haven't covered all the conceptual video of beta and gamma, so please learn it before coming to this question sessions video. Okay. So now we have to cover the question and we will see whichever question we have to cover. So simple, we have to cover not only 10, we have to cover, yes, all the questions, but not merely in this video. Okay, we will consider all the questions one by one. Okay, so in this video, we will cover only this question. Again, in next video, this, and continue. Okay, so now we will cover this question. So let's come to the question without wasting any time. So just coming to the question. So just now read it. Okay, first read it. 0 to a x square. A square minus x square 3 by 2 dx. Okay. Now think you by yourself. Yes, before coming to the approach, how to solve it. Yes, so let's see the approach. So we have to identify the limit first. Identifying limit means what? We have only three standards limit. Like we know that in beta mn, yes, in beta mn we have three limits, and in gamma we have 0 to infinity. Okay, so this is the standard definition of gamma. Okay, 0 to infinity to the power minus x, x to the power n minus 1. Okay, in gamma we have come across 0 to infinity. In beta we have come across three limits. Okay, 0 to 1, 0 to pi by 2, and 0 to infinity. Okay, so keep in mind that eventually we have to come across this limit, not the awkward limit in 0 to a, like in question. 0 to a, what is here? X square, a square minus x square to the power 3 by 2 dx. 0 to a, this is awkward limit. We don't need it anyhow. Okay, so we have to transform it. This is our second point. So we identified the limit. This is not of our use. Okay, so we will substitute. Okay, so substitute, yes, we will transform and we will anyhow convert in this standard limit. Okay, so this is clear to you. First point. Second point is also clear, that how will we change the limit? Simple, we have to transform by using the substitution method of integration. Okay, substitution method of integration. So how will we substitute? This is the first question and this must repeat in your mind, that how to substitute. Okay. So let's think for a while before coming to the third step of approach. Okay. So think. Yes. If it isn't so, then I will tell you. Okay. So use relations of beta and gamma wherever necessary. That means what? When we will delve and dive down into the calculation, so we will use the relations of beta and gamma, and whichever relations is important, we will use it. Okay, so this was our all the approach. Okay, so first we have to identify the limit 0 to a, no, this is not matching. So we will transform it. Then how? Then by using substitution. Clear? Very clear. Then what will we do? Simple, we will use the relations of beta and gamma in the calculation. Okay, so this is clear to you. So now coming to the solution, that how to substitute, and I will tell you the approach of substitution also instead of cramming it. Okay, so here which is our problem? Our problem is a square. Yes, clear. And a square we don't want to see, and we don't want to see x square. Why am I telling like this? So that's why concept is important, and I hope you remembered all the transformation of beta mn. If isn't so, then I am writing. Okay. So please, if isn't so, then must remember it. Okay. These are the definition of beta mn. Okay, beta mn. So we have to substitute this integration and we have to transform this limit into this limit. Okay. So what will we substitute? This is the first question. So simple, we will substitute the variable of integration, which is x. Okay. So now x is equal to what? This is the question here. So a square minus x square. Either you can transform this into this standard integration or this standard integration. In this, we are gonna have some lengthy calculation. Okay, lengthy. No, you can also try like how to convert a square minus x square into 1 minus x. Just think. So something is clear that we have to take x is equal to square root of something so as to get this term x. Okay. So instead of doing this, I will prefer to use this. Okay. I will convert this term into the trigonometric ratio. Okay. So now think that how to convert. Now just don't care about this limit because we know the standard definition. So just care about this, then automatically we will see the magic that limit is transformed. Okay. So now we will put what x is equal to think a sine theta. Yes. Why? Why again ask why? Because something like this in this page I will tell you 1 minus x square. We put x is equal to sine theta. Then this is simple that 1 minus sine square theta. Then this is very simple that this is cos square theta. Clear? And when we put x is equal to sine theta, then we get dx is equal to cos theta d theta. Clear? Very clear? So we are getting cos here and sine here. Clear? That's why we use x over sine theta. But when we come across minus 1 minus x square, when we will come across 1 plus x square, we will substitute x equal to either tan theta or cot theta. Okay, clear? So here we are coming across a square minus x square. So we will put x equal to a sine theta because a square sine square theta so that we can take a square common. So this was all the approach. Okay. So we will substitute x equal to what? A sine theta. Okay. Now very clear. Now we will see that what we have done. Yes. Here check it. X is equal to a sine phi. You can substitute phi or theta. You can take it. Okay. This is a variable. So simple. Dx is equal to a cos phi d phi clear and ul that is pi by 2 and ll means lower limit here and ll means sorry ul means upper limit and ll means lower limit. Upper limit is pi by 2 and lower limit is 0. It's obvious that when x is equal to 0, so sin theta is equal to 0, so theta is also 0. This is lower limit. And when x is equal to a, why is this so? Because question 0 to a, so x squared a square minus x squared to the power 3 by 2 dx. Okay. So when x is equal to a, so a and a are cancelled. Okay, clear? So sin theta is equal to 1, so theta is pi by 2. This is clear to you. So we can easily write this integration as 0 to pi by 2 1 1 1 when sin theta is 1 when on angle pi by 2. Okay, so this is 0 to pi by 2 and x squared is simply a square sin square phi here. So you can take phi or theta whatever. We will take theta. Okay, because I have taken it already. So a square sin square theta clear. So now 1 minus x square. Sorry, a square. This is the question. A square minus x square. X is equal to a sin theta. So a square sin square theta clear to the power 3 by 2 and dx is equal to clear a cos theta d theta clear. Now this is very simple 0 to pi by 2 a square and this is a squared as well, so we will take a square common. So we will see that how to solve it. Simple, we will take a square common, so a square will come out of this bracket. But how? 2 into 3 by 2 because this is the power. Okay, so a square into a, that is a cube, and a cube into a square into 3 by 2, that is 2 into 3 by 2. So 2 cancel with 2, so a cube and a cube here, so this will become a to the power 6. A square into a cube and this is a cube also. Clear? And sine square theta and this is 1 minus sine square theta. And this is for 3 by 2 and this is cos theta d theta. Clear? So this is very clear 0 to pi by 2 e to the power 6 sine square theta. This is cos square theta to the power 3 by 2. So 2 into 3 by 2 again what? cos cube theta, and this is cos theta. So we can write cos 4 theta d theta. This is very clear. So let's see. Yes, this is very clear. 0 to pi by 2 a to the power 6. How? Because this is simple. A to the power 6 a square a cube and a cube from here. Clear? And sine square phi clear, sine square theta, yes, and 1 minus sine square phi and 3 by 2 clear. So this is clear, and we will assume it k I, anything you can assume. So now just identify which is the form. I already told you, that's why concept is important. So here this is very clear that now above integral is in the form of 0 to pi by 2 sine p phi cos q phi d phi. That means this is the form that I already told you, and this is derived from the relation between beta and gamma. So simply what we used to do, we used to take the value of p plus 1 by 2 inside gamma, and again we multiplied it. Simple, this is the formula. So we will put 2 and 4. The 2 is the value of P and 4 is the value of Q. This is the value of P and this is the value of Q. We will use gamma P plus 1 by 2, gamma Q plus 1 by 2 upon 2 into gamma P plus Q plus 2 upon 2. Clear? So P plus 1 by 2 we will discuss in this years. So P plus 1 by 2, 2 plus 1 by 2. Okay, and this is Q plus 1 by 2, this is 4 plus 1 by 2, and upon 2 plus 4 plus 2 by 2 into 2. Okay, and this is a to the power 6 is coming with here a to the power 6, a to the power 6, a to the power 6 also. Okay, clear? This is multiplied. So this is the value of integration, and a to the power 6 is a constant. Clear? So this is multiplied with this. Now we will solve gamma. So gamma 3 by 2, this is gamma 5 by 2, and this is 2 into gamma 4 plus 2 plus 2. What is this? 8. Okay, by 2 that is 4. So gamma 4, no any problem. Now 3 by 2. How to solve it? I already told you that whenever the term is greater than 1, this is 5 by 2 greater than 1, this is 3 by 2 greater than 1, something that means 1 plus something. So 1 plus x or 1 plus m. Okay, 1 plus something. So we will transform in this into this form. Okay, so how to write 3 by 2 in 1 plus n? I hope you remembered, yes, 1 plus n, yes, gamma 1 plus n, recurrence relation. That must strike in your mind. Okay. So now gamma 1 plus n we will use. Okay. So 3 by 2 we can write 1 plus 1 by 2. So gamma 3 by 2, gamma 1 plus 1 by 2, and we know that what? What we know, yes, gamma 1 plus n is equal to n gamma n. Okay. So 3 by 2, 1 plus 1 by 2. So we can write 3 by 2 as 1 by 2 gamma 1 by 2, and we know that gamma 1 by 2 is equal to root pi. Clear? Similarly, we can write 5 by 2 gamma 5 by 2 1 plus gamma 3 by 2, and we can write 3 by 2 gamma 3 by 2 by using this relation, because what is the value of n? N is equal to 1 by 2 here, and n is equal to 3 by 2 here. Clear? Clear? The 1 plus n. Okay, so 3 by 2 n gamma n, so 3 by 2 gamma 3 by 2. And we know that how to solve 3 by 2. Again 1 plus 1 by 2. So 3 by 2 into 1 by 2 gamma 1 by 2. So we just have to go till 1 by 2, and we have to subtract 2 from the numerator. That 5. Then start with the 7 if gamma 7 by 2. So simple, right? 1 plus 5 by 2. So start with 1 plus 5 by 2. Okay. So start with 5 by 2 gamma 5 by 2. Clear to you? And repeat it again, 5 by 2 into 3 by 2 gamma 3 by 2. So again repeat it, 1 by 2 gamma 1 by 2. So this is root pi. Clear? So we can easily write now 3 by 2 as 1 by 2 into root pi. Clear? 5 by 2 as 3 by 2. Yes. We will keep going unless and until we come across 1 by 2. So 3 by 2, then 1 by 2. So we will stop. And we know that gamma 1 by 2. So this is root pi. Okay, upon this is what? 2 into what? Gamma 4. We know that gamma n is equal to what? Gamma n is equal to, yes, n minus 1 factorial. This is very important. N minus 1 factorial. So gamma 4. So this is 3 factorial. So now root pi is pi, and simple is the calculation, 3 upon This is what? 6 into 2, and this is 2 into 2 into 8. So this is 6, and this is into 2, and this is 8, okay, and this is 5. And a to the power 6 is coming, so write it a to the power 6 here, a to the power 6, okay. A to the power 6, and this is what? 12 into 8. Okay, so 3, 2, 2. 8 for the 5, a to the power 6 upon 32. Clear? So this was the solution. So let's see. Simple, yes. A to the power 6 gamma 2 plus 1 by 2, gamma 4 plus 1 by 2, and a to the power 6. Simple, like we did. Okay. So how to write 2 plus 1 by 2, gamma 3 by 2, and 1 by 2, 1 by 2, how? Again using recurrence relation, this relation. Sorry. 1 plus, uh, here, here to write it. Gamma 1 plus n is equal to n gamma n. Okay, I already told you. Okay, so 1 by 2 gamma 1 by 2. Why is this so again? 1 plus 1 by 2, so 1 by 2 gamma 1 by 2 clear. 3 by 2 gamma 3 by 2 clear to you. So this is 2 into how this came from this formula. And what is this? This is the value of this. And why is this so? Because we learned it from the relation of beta and gamma. Okay, we derived it. Okay, so must watch all the videos if your concept is lagging. Okay, so now this is very clear. And a to the power 6, a to the power 6, this is equal to this equal to this, and 5 by 2 is 3 by 2, gamma 3 by 2, and 2 into 4 plus 2, that is 8, so upon 2, so 4, gamma 4, so sorry for this mistake, not gamma, so only gamma 4, so gamma 4 is equal to 2 into 3 factorial, clear? So we will solve it and we will see the result, pi by 32 e to the power 6. This was all about this question. Okay, I hope you have enjoyed, learned you can win some style in funny style. So thank you for staying so long. We will see next question in next video. Okay, again thanks for watching.